Hello everyone. In today's lectures, we'll be continuing our discussion of control structures, as well as expand our previous understanding of operators with logical operators. Today you will learn how to implement counter-control loops in C, how to interrupt loops, what are switch statements in C, and how to use logical operators. Last time we discussed sentinel control loops, where the amount of times said loop will repeat are unknown to the program before entering it. We would use this for problems where circumstances may be constantly changing or where the loop starts with imperfect information. On the other hand, a counter-control loop will execute a set amount of times, usually determined when said loop begins. We use this for problems where the number of times the task will be repeated will generally never change while it's running. In C, we know this type of loops as for loops, and are leaded by a for statement at the top that uses a control variable to know when it's time to end. Look at this example from last week. Notice that the value of inputs will determine when the loop will repeat after getting to the end. In counter-control loops, this is usually a variable that serves as a counter, and since counter-control loops are defined by the need to keep count, we have a dedicated name for the variable used to do so. We call it a control variable. A for loop is structured identically to a while loop, except that instead of writing a while statement, like you see here, we write a for statement. A for loop is made of three parts: the initial value, the condition, and the increment and decrement. The initial value assigns the initial value of the control variable, for example, x equals 0. The condition is checked at the end of each iteration to determine if the loop should repeat, for example, x less than 10. And the increment or decrement is the loop what should happen to the variable after every iteration before the condition is checked. For example, x is written as x plus 1, also written as x plus plus. So if we compare this while loop as we see on the right with the for loop that we see on the left, you can see that the first part is equivalent to determining the value of a variable before the loop starts. The second part is the condition for the loop to repeat. And the third part is what happens at the very end after anything else. Before we write our first for loop, I want to point out a couple errors when it comes to for loops. First, there are two and only two semicolons inside of the for statement. They're used to divide each part of it. Do not put a semicolon after the increment or decrement. Second, just like with while statements, you do not write semicolons between the statement and the curly brackets that indicate the body of the loop. Doing so will make the loop think the body is only the semicolon, causing errors. And third, one, our example, we declare x as a control variable that existed solely within the for loop by creating it in the initial value. It is possible to use pre-existing variables. You simply will remove the type, indicating that you're changing the value of the variable, not declaring a new one. With that out of the way, let's write a for loop. Alright, I took the liberty of starting my Visual Studio project ahead of time. You guys can go back to previous lectures if you have questions about this. So I want to make a for loop that prints the numbers between 1 and 100. So to make a for loop, you first write for, then go parentheses. The first component of a for loop is going to be the initial value. For this, I'm going to declare a new variable that's only going to exist within the for loop. So for that, I'm going to write first the type, then the name. I personally go with n, but it's more common to use I. So I. So we want to start with 1, so I is equal to 1. The semicolon. And this semicolon is a little misleading as it is. I'm going to put a space before it because it's a little closer to how it actually works. It's a divider, not really something that ends the statement before it. In the middle, I'm going to say, well, I want to keep repeating this loop as long as I is less or equal than 100, right? Because it's between 1 and 100. I don't want to print 101. I don't want to print minus 1. I'm just going to go between 1 and 100. So as long as I is less or equal than 100, we're going to keep repeating this loop. The moment I becomes 101, we're going to stop it. Which brings us to the third component of a for loop, which is going to be the increment slash decrement, which is what happens in between each iteration of the loop. We're just going to add 1 to I every time. So I plus plus. This is also the same as writing I plus equals 1 or I is equal to I plus 1. These are all the same thing. It's more common to write I plus plus. And for the body, I'm just going to add the curly brackets just like I did with the while loop. And here I'm just going to print the current value of I. So printf, then %d, I'm going to add a space in between, and then comma I. And what's going to happen is every time the loop repeats, the value of I is going to change. Whatever printf is going to use to print, it's going to change, right? Because the value of I changes, it prints the current value of I when it gets to it. I'm going to add that, and then I'm going to add a printf after the for loop that is just a new line. And this will just make sure there's space between the numbers and the pause. And if we run our program, and here we go, numbers from 1 to 100. Sometimes, be it in the interest of efficiency or to prevent fatal errors from crashing your program, you want to interrupt loops. In C, there are two ways of doing this. The first is break, which will exit a loop. And the second is continue, which will skip the rest of the core iteration of a loop. Let's discuss them in more detail. When the break statement is executed inside of a for loop or switch, the program will immediately exit the loop or switch and move after its scope. For example, the snippet of code on the right will produce the output under it. The for loop only executes 5 times, technically 6 is become the 0, as once it reaches the if statement, the loop will be exited. Let's see a quick use of it. Okay, so we're back in our for loop, and I'm just going to make it so it stops the moment that it reaches a number that's divisible by 10. So for that, I'm going to add an if statement. And how can we tell if a number is divisible by another number? Remember, we just divide them and get the reminder using the percentage sign. I, percentage sign 10. This will give me the reminder of division between I and 10. If that reminder is 0, which means it's divided by it, it's divisible by it, we're going to break the loop. I'm just going to write break. The moment the program gets to that line and I is divisible by 10, it's going to break the loop. So the first time this happens when I is equal to 10. So let's run our program and see what happens. And just as we predicted, when I gets to 10, so I is 1, I is 2, 3, 4, 5, none of these are divisible by 10. 10 is. And because this is getting broken before it gets to the print, we don't see the 10. It just immediately exits the for loop and then continues to the next of the program. When the continue statement is executed inside of a loop, the program will immediately skip to the start of the next iteration without executing anything after it. For example, the snippet of code on the left will produce the output under it. The for loop executes 10 times, but 5 is never displayed, as the printf is skipped when the continue is executed. Now let's just continue instead. Okay, we're back here. Now let's say instead of just exiting the loop when it gets to 10, we want to just skip all the numbers divisible by 10. So instead of using break, I'm going to just continue. So again, I is 1, I divisible by 10. It's not because I divided by 10 has a reminder, it's 1 actually. And it's going to continue, prints I. And it goes on, I is equal to 10. I divided by 10 has a reminder of 0 because there's no reminder then. In which case, it will just continue, which means it will immediately go here and continue the process. So it will skip over this print. So what we'll see is we're not going to get 10, 20, 30, 40, 50, 60, 70, 80, 90, or 100. So let's run our program and see what we see. Okay, so as we see, 10 is not listed, neither is 20, neither is 30, and so on and so forth. 100 is not listed as well. Last, let's talk about if and if-else structures. Well, these are great and something you will keep using throughout your entire career. Sometimes they can get inefficient and hard to read when you are doing everything based on a single variable. Let's say, for example, that we want to print the name of the month based on the numeric value of the variable m, where 1 is the January and 12 is December. This is how you'll do it with if-else. So m is equal to 12. Is m equal to 1? No. Well, is m equal to 2? No, and so on and so forth to get to 12. This is not only cumbersome, but also inefficient, as our compiler doesn't know that m is the only variable being checked against, so it treats this like it would treat any other else if. A better way of writing a statement like this is using switch multiple selection statements. In a switch statement, a single control variable is checked against multiple cases, and whichever case is correct will be executed. Let's see our previous statement repeating as a switch statement. You can see that m is equal to 12. Then he says, okay, I'm going to check the value of m and compare it against every label here. And whichever it is, I'm just going to jump to it. So m is equal to 12. And it just goes straight here. Some things to notice. Instead of a condition being inside parentheses, in a switch statement where the variable we would check all cases against. This is known as the controlling expression. Next, its case level reading case value. Do not confuse the colon after the value with a semicolon. Next, at the end of each case, there is a break. This is to prevent a case from falling into the next one. The break statement works just as it does with loops, skipping the program flow to a line after the structure ends. And lastly, default serves the same purpose as else in an if-else structure. If none of the previous cases are true, that's the one executed. Let's use it in an example. Okay, so I took the liberty of commenting the stuff that we did before. And we're just going to have a program that prints the 7 days of the week using a for loop and a switch statement. We're going to make a for loop for this. So the for loop is going to start with 1. So int, let's say d in this case, for day, equal to 1. That said, usually in loops, we start with 0. In programming, it's very common to start with 0, just because it's a little more natural for a computer to think that way. So let's do 0 in this case. So int d is equal to 0. Semicolon for dividing, as long as d is less than 7 in this case, because if we count 7, it's going to go 0, 1, 2, 3, 4, 5, 6, 7. That's 8 times rather than 7 times. So as long as d is less than 7, d++. Okay. Okay, now we will fill this with the cases. So case 0 is going to be Sunday. Because we're starting with 0, 0 is going to represent Sunday, then 1 is going to be Monday, Tuesday, so on. This is just something that you get used to it. It makes more sense once you get the hang of it a little more and practice it a little more. if case0 is going to print Sunday, we're just going to write printf Sunday and add a new line to make sure that it doesn't get mushed with the next line, and then a break. Now let's continue to the next one and I'll tell you what's going on with the breaks. So case 1, printf Monday, break. So without this break, if I remove this break, what's going to happen is it's going to do what's in here and immediately it's going to follow on through this. There's nothing telling it to stop after it's done here. The break makes sure that it exits the switch statement. Something that I want to point out is that this break is only affecting the switch statement. It will not affect the loop that's outside the switch statement. So that's something important to keep in mind. You cannot affect a loop from another loop using a break. So let's repeat this with the next stays, including the default statement. I'm just going to do that off camera right now. Okay, I also forgot to add the new line before. I just did this with the rest of them. And let's go to the default statement. So the default statement is going to be the equivalent of an else in an if-else statement. So default just basically executes if none of the other cases are true. So it's going to say something like a printf wrong value. It should not be present in our current loop. However, it's important to always have a default statement in case something happens. So let's run a program and see how it looks. Okay, and there we go. Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. So let's say I'm going to just add a new line in between each of these. And I'm going to remove one of the breaks so you can see what's going on. So I just removed the break on the first one. And let's see what happens when I run my program again. Notice what I said earlier happened. It got to Sunday, it prints Sunday, but there was nothing telling it to stop. So it's continued to the next one and printed Monday. I know this might seem a little weird, just the way the switch statements work, which is why we always put that break in between to make sure that this doesn't happen. That's why we got Sunday, Monday, and then Monday, Tuesday, Wednesday, because it goes to 0, it does this, falls into the next one. However, when it goes to this one, it doesn't fall to the next one, it breaks, it gets out of it, and it just continues again. When discussing if statements last class, we use equality and relation operators to make decisions. More than, more equal than, less or equal than, equal, and not equal. You're likely familiar with all of them as they're using math to formulate a relationship between two numbers. However, in the real world, there's often more than one condition at play. To handle multiple conditions at the same time in the relationship, we use logical operators. And returns true if the statement to its left and right are both true, or returns true if either the statement to its left or right is true, and not returns true if the statement to its right is not true. While it's sampled today and likely during the rest of the semester will be quite simple, it is interesting to notice that logical operators can be combined very intricately. Logical operators are executed left to right according to the operator precedence list. This means not only that n is checked before or, but that you can use parentheses to forward parts of the condition to be checked first. The following statement will print false. Do you see why? Let's use them in an example. Okay, so here I'm again. I already commented out the stuff that we did on the last example. So what I'm going to do is I'm going to write a short program that asks the user for their age, and then it's going to do something depending on what that age is. So I'm going to start making the variable, and it's just an integer. There's nothing like 6.5 years old, at least not formally. So we're just going to make that an integer. So int age. Then we're going to prompt the user. So print f, and we're going to say enter your age. Semicolon. Then scanf underscore s to actually get the user input. So %d because it's an integer, not a float. And then comma and %age. So this will do the user input into the age variable. And now we can actually do stuff with it. So let's say this is a park, and it includes a discount if you're between the ages of 1 and 12, including 12 and 1. So we can say if age is less or equal than 12, because we're counting 12. And this is the important part. We say n age is more or equal than 1. We're saying, is age less or equal than 12? Yes. Is it also more or equal than 1? Yes. Then that means it's between 1 and 12. If we just say this, it's not going to know how to interpret that. We need to tell it specifically that we mean age is more or equal than 1. So if that happens, we're going to say printf, you get a discount. Okay. Now let's say that we also offer a coupon if you are 18 or 21. So we can say else if, we're going to say if your age is equal to 18 or your age is equal to 21. Then we're going to say you get a coupon. And again, notice that in both cases, I'm specifying that I mean DH both sides of the logical operator. I'm saying, is age equal to 18? If it's not, then we're going to check if his age is equal to 21. Fun fact, if this is true, this is going to be skipped. If this is false, it's actually going to check this one. The thing with OR is that only one of the conditions must be true, not both of them. If both of them need to be true, that's an AND. That's %. If it's OR, it's 2 vertical bars. Finally, let's say this part also will not let you enter if you are a newborn for any reason. So I'm going to say else if, and I'm going to say, is the age of the person equal to 0? Then they're a newborn. In that case, then we're going to display a message. So is age equal to 0? They're going to say printf, you cannot enter. However, newborns do not know how to read, so maybe we just immediately just forbid them entry. So else if age is not equal to 0, so not equal to 0, we're just going to say welcome, because if they're not equal to 0, we can allow them to come in. And we're not going to get an else for this one because we're not going to do anything if the age is 0. If the person is a newborn, they're not going to get an indication, they're not going to get a welcoming, they're just, they get nothing. So let's run the program and see what we get. Okay, so if my age is 0, it should show me nothing. It shows me nothing, just exit the program. If my age is 8, then I just get a discount. And if my age is 21, I just get a coupon. So 21. That's it. I also want to point out that due to the nature of if and else if, these are exclusive to each other. Let's say we set the range of the coupon to 18. What that means is that I will never get a coupon because this will be true, and because this is an else if, it's never going to execute. If you want conditions to be able to execute and stack on each other, then you will not make them else. Then you'll make them if they're right after each other. And that is it for today. Please complete this week's reading as there's more useful information in it that I had to leave out due to time. Don't forget to submit this week's assignment and discussions as well. As usual, feel free to reach out to me if you have any questions, otherwise I'll see you all next week. Take care.